So now I want to go to story 3. Story 3 takes the story of life to Mars even further, and that is making Mars habitable for life, long-term habitability. We know that Mars is a planet with a past, a past that was wet. Here is a world that was wet. It was a water world. At one time, we had 2 blue marbles in our solar system. Somewhere along the way, we lost one of our marbles. Why? Well, we think we know how it became the cold world it is today, but we also think it could be brought back. How do you bring Mars back? Well, the fundamental challenge here is to warm up the planet. We know how to warm up planets. We're doing it right here on Earth. We are practiced in that technology. And in fact, you could do the same thing on Mars, and you can imagine today and in the future, you notice the difference? Plants. Keeps coming back to plants. When you look at the Earth, it's a planet of plants. You fly over in an airplane, you look down, what do you see? Plants. Animals are small, furry things that run around the edges. The world is dominated by plants. The biosphere is dominated by plants. As I said, we can make Mars warm the way we're making Earth warm with super greenhouse gases. This is just a short diagram of the physics of how they work. They plug up the hole in the greenhouse blanket. We've learned the hard way on Earth not to use chlorine and bromine. Chlorine and bromine destroy ozone. We want to have ozone on Mars. We want to have ozone on Earth. But there's plenty of greenhouse gases that don't involve chlorine or bromine. And this is a calculation by a former grad student, now a postdoc, of the warming on Mars as a function of these different gases per fluorocarbons. And you could warm up Mars appreciably with parts per million of these gases. So this slide is, in a sense, the bottom line. How long would it take? And we can approach the problem essentially as a simple physics problem. Here's Mars today. Think of that as the before state. And here is Mars warmed up. That's the after state. It represents a change in energy, delta E. The only plausible energy source for that energy is the photons from the sun that are incident on Mars. If you calculate how long that would take and put in a reasonable efficiency for warming up planets with a greenhouse effect of 10%, it only takes 100 years of sunlight at 10% efficiency to warm up Mars. So this is not something that is thousands of years in the making or millions of years in the making. That's to warm Mars. On the other hand, to make it oxygen rich, using the efficiency of Earth's biosphere, which is 1/100%, it takes 100,000 years to make oxygen. So we can easily imagine with technologies we understand and have demonstrated that we could warm up Mars. We cannot imagine how we can make it breathable in the sense of Earth's atmosphere. Something, not everything one might like, but something. Why to do it? The fundamental reason, I think, that we would do this traces back to the statement on Feynman's chalkboard the day he left. What I cannot create, I do not understand. What are we trying to understand? This is what we're trying to understand. We're trying to understand the Earth. So I think an important motivation for investigating Mars, investigating life on Mars, investigating the possibility of bringing Mars back to life is the fact that we humans, whether we want to or not, must assume management responsibilities for our planet. There's just too many of us not to assume management responsibilities. It would be a dereliction of duty not to assume that we are responsible and must take it. And we have to learn how to do that. And one of the ways of learning how to understand something is investigating how you would create it. And that is the slide that tells me I'm at the end of the formal presentation, and we can go to questions and answers specific to this before we go to the panel. Question here, Al?
How do we send people to Mars without contaminating, biologically contaminating wherever they go?
You can. You do. Let me just answer that question by pulling up some other slides. Here's Al's question. Don't send humans because they will contaminate Mars before we have a chance to determine if it has life and its potential for life. And it's a very good question. And it's a question that, at least within NASA, we don't ask ourselves, partly because we have two dysfunctional Mars programs, one that focuses only on science and one that focuses only on humans, and they don't talk to each other, and they're bureaucratically separated from each other. They get funding streams, so they view themselves in competition. So right now, NASA has two Mars programs that compete with each other. One rooted in the old vision for space exploration and sending humans to the moon and on to Mars, and one rooted in the Mars exploration program with rovers. And they are not coordinated, and this is one of the places where they must coordinate. And this question of how can you, don't send humans.